Power functions are an instance of a more general class of functions called polynomials. An example of a polynomial which is not necessarily a power function is a quadratic function. Another example of a polynomial function which is not a power function would be a cubic function that's been shifted either up or down. In general, a polynomial function is a function of the following form. Let's identify some useful terms of a polynomial function. The terms underlined in blue are referred to as coefficients. The part that's been circled in yellow is referred to as a term. And we also note that for polynomials, the leading term an is non-zero, and n is an integer, where we also have that all powers of our polynomial are integers. Let's go ahead and identify which of the following are polynomial functions. In part A, we're given h of x is equal to 5 times the square root of x squared plus 2. Let's go ahead and rewrite this as 5 times x squared plus 2 raised to the 1/2. So this is not a polynomial because the powers of polynomials are all integer numbers that are greater than 0. And the power given here 1/2 is a fraction. In part B, we're given g of x is equal to x times x squared minus 2 divided by x. Again, let's go ahead and simplify this. This will be equal to an x cubed minus 2. Here we clearly see that by definition, this is in fact a polynomial. The general form of a polynomial comes from the definition and can be seen below. Let's identify more important terms. The leading term of a polynomial is circled in yellow. And by definition, the leading term contains a variable of the highest power. The highest power of a variable of a polynomial is referred to as the degree. And the leading coefficient is the coefficient of the leading term. Notice that the leading term is a power function. This power function inside our polynomial will determine the end behavior of the graph of our polynomial function. Before we study the end behavior of a polynomial, let's first identify a leading term. In this problem, we're given that f of x is equal to 4x squared minus 6x to the 6 plus 2x minus 6. And let's identify the degree, the leading term, and leading coefficient of this polynomial. First, we need to rewrite this polynomial in general form, which means we need to rewrite this so that our x's have powers of decreasing order, where the largest power goes first. Then this is going to be equal to a negative 6x to the 6 plus 4x squared plus 2x minus 6. Then the leading term of this polynomial is going to be negative 6x raised to the 6. And the leading coefficient is then given by a negative 6. And the degree of this polynomial is 6. The end behavior of a polynomial function is determined by the leading term of the polynomial. This is because the power of the leading term is the highest, and this term will grow significantly faster than all other terms, which means the leading term dominates the behavior of our function. To summarize, the end behavior of a polynomial is determined by the leading term of the polynomial, which is the given power function. Let's go ahead and review the end behavior of power functions. Again, when an is greater than 0 and n is even, the end behavior of a graph will look something like this. When an is greater than 0 and n is odd, the end behavior of a graph will look something like this. In this case, we'll be looking at when our an is a negative number. So when an is less than 0 and n is even, then the end behavior of a graph will look like the following. And when an is less than 0 and n is odd, the end behavior of our polynomial function will look as follows. Given the polynomial f of x is equal to x minus 2 times x plus 1 times 5 times x minus 5, express this in general form, then determine the end behavior. To express this polynomial in general form, we need to go ahead and FOIL this out. So let me rewrite our polynomial. We'll have an x minus 2 times an x plus 1 times 5 times an x minus 5. We'll go ahead and FOIL the first two terms together as follows. And then we'll distribute the 5 to the fourth term here. Simplifying this, we should get that this is going to be equal to x squared minus x minus 2 times a 5x minus 25. Again, we'll go ahead and FOIL out the first term. Simplifying this, we should get that this is going to be equal to a 5x cubed minus 25x squared minus 5x squared plus 25x minus 10x plus 25. Simplifying this, we'll get that this is going to be a 5x cubed minus 30x squared plus 15x plus 25. Here we see that the leading term is a 5x cubed. The degree of our polynomial is 3, and the leading coefficient is a positive 5. Therefore, the end behavior of our polynomial is determined by this power function here, which means the end behavior of our polynomial will look like the following.